Okay, hi guys. Today we're going to be doing what's called solving a systems of equations. And we're going to use one of three methods today. This is going to be the substitution method. So just to get some basic information about what a systems of equations is, what we're going to be doing is solving for two different variables. So for instance, an x and a y at the same time. And in order to do this, you have to have two equations. You can't do it with just one equation. Think of it this way. If I said x plus y equals 7, there's a lot of different answers you could give me when we have two variables. There's not just one solution. I could say, well, x is 1 and y is 6. Or x is 2, y is 5. I could give a whole lot of answers. In fact, there's an infinite number. So we can't solve for two variables unless we have two equations. Okay, we can actually do more than two variables, but that would require more than two equations. So for instance, if you needed to solve for three variables, you would need three equations. Four variables would require four equations, and so on. For this particular lesson today, we are only going to be dealing with two different variables, no more. So let's look at an example. Here's a systems example. It says I have 20 coins in a jar. Some of them are nickels and the rest are dimes. The total value of the coins is $1.40. So how many dimes and how many quarters were there in a jar? The only way to solve this without having to start doing guess and check is to solve it using a systems of equations, and I'm going to show you how to do that. First step is to find our two equations. So we do have to write two equations. Since we have two different variables, I'm going to call N nickels and D dimes. So we're going to use N and D so I know which one's which. Those are my two unknown variables. I don't know how many nickels and I don't know how many dimes we have. But what I do know is that I have a total of 20 coins. So that means if N is the number of nickels, so you always want to label your variables. D is the number of dimes I have. So if I know I have a total of 20 coins, that means the number of nickels plus the number of dimes should be 20. I could have 10 of each, I could have 9 of one and 11 in another, something like that. But they have to add up to 20. The other piece of information I'm given is that they are worth $1.40. That means if I were to actually calculate how much money they're worth, it would be $1.40. Now, to do this, I'm going to have to set up an equation where I'm calculating how much money I have. If N is the number of nickels I have, in order to calculate how much money that is, I take the number of nickels I have and I multiply it by 5. So 5 times N tells me how much the nickels are worth. Since dimes are 10 cents each, I take my dimes and I multiply that by 10. So if I take the value of the nickels, which is 5 times N, plus the value of the dimes, which is 10 times D, that should equal $1.40. And I have to write that as 140 cents. Since I didn't use decimals for my 5 and my 10, I'm using 5 cents. I'm keeping everything in cents right here. You have to keep it in the same value. You could keep it in dollars, in which case you'd have $1.40, but your nickels would have to be 0.05 and your dimes would have to be 0.10. So you have to choose. You're either in cents or you're in dollars for everything. Okay, so I'm in cents. Now I need to figure out how to solve. I have two equations and two variables to solve for. So this is how the substitution method works for this. You're going to take one of your equations, ideally the one that looks simpler. So in this case, this one looks a little simpler. I'm going to use this one. I'm just going to rewrite it down here. And what you're going to do is you're going to isolate one of those variables. Either the N or the D, it doesn't matter which one. I'm going to do the N. So I'm going to get N by itself. And to do that, I'll subtract D from both sides. So that gives me N equals 20 minus D. So you pick one of your equations and you isolate one of the variables. It doesn't really matter which equation or which variable you pick. It's just easier to do the one that looks simpler, that doesn't have the coefficients in front of the letters, if possible. Now, this is where we do the substitute part. Now that I know that whatever n is, that's equal to 20 minus d. That means the letter n and 20 minus d are interchangeable. They mean the same thing. They are the same exact value. Wherever I see an n, I'm allowed to replace it with 20 minus d because it equals n. It means the same thing. So it doesn't matter if I write an n or if I write a 20 minus d. So the next thing is we're going to do our substituting. So we're going to substitute 20 minus d for n in the other equation, not the one I just used, but the other one. So you're essentially going to rewrite the other equation, but you're going to replace the n with 20 minus d, since we determined that they're equal. So here's what I mean. This is the equation I'm talking about. Instead of writing n, I still have to write the 5. I can't take the 5 out. I'm just replacing the letter n. Instead of writing the letter n in parentheses, you always replace things in parentheses, I'm going to replace that n with 20 minus d. So I'm substituting 20 minus d in for n. And then I'll rewrite the rest of that equation. So we rewrite that second equation, replacing n with 20 minus d. And this is what it would look like. And now I just solved, because the point was, when I did that, now I have one variable in my equation, and I know how to solve an equation that has one variable. I can start solving. So I'm going to go ahead and solve. We start off by distributing. That's 100 minus 5d plus 10d equals 140. Combine like terms. 100 minus 5d plus 10d is plus 5d. Subtract 100 from both sides. The hundreds cancel. 140 minus 100 is 40. So 5d equals 40. Now I divide both sides by 5. And d equals 8. That means I have 8 dimes. So if I have 8 dimes, now what I can do is go back and look at one of these other equations or information I knew. For instance, I know that there's supposed to be a total of 20 coins. So if my d equals 8, then I can just replace the d with an 8 and solve that equation. You can probably do that in your head, I know, but this is how you would do it if the equation wasn't quite so simple. So if I have 8 dimes, then I have 12 nickels. And that's your answer. There's 8 dimes and there's 12 nickels. So that's how you solve a system of equations. Let's look at another example. Okay, here's a different problem. We have the sum of two numbers is 24. Their difference is 4. So what are the two numbers? We have two unknown numbers. We don't have any information about them. It's not like the previous problem where they were nickels and dimes, so I'll just call them x and y. Sum means that we add. So when we see that, we know the sum of these two numbers is 24. That means x plus y equals 24. Difference is the other thing they tell us. That means subtract. Their difference is 4. So when I subtract them, I get 4. So I know if I add x plus y, it's 24. X minus y is 4. Those are my two equations. Once you have two equations written with two variables, you can start solving using substitution. So we pick one of our equations and we isolate a variable. It doesn't really matter for this one. Both of these equations are pretty simple to use. So I'm going to just pick this one to isolate, that x in that equation, which means I'm going to be adding y to both sides. And that gives me x equals 4 plus y, or y plus 4, either way. All right, so that's first steps, isolate a variable. Second step is we're going to do our substitution. We're going to substitute 4 plus y for x in the other equation, the one I didn't already use. So I'm going to rewrite that top equation, and I'm going to replace the x with the 4 plus y. Now, for this one, we can put the parentheses, but they're not necessary since everything in this equation is addition. So in this case, the parentheses aren't really necessary. All I have to do now is combine like terms and solve. Now I have an equation that only has one variable. So I know how to solve this. Y plus y, combine like terms, you get 2y. Subtract 4 from both sides, we get 2y equals 20. And then divide both sides by 2, and you get y equals 10. So that means one of my values is 10, one of those unknown numbers. And I knew that their sum was 24, so if I take this information, maybe come back to this, x plus y, which is 10, is equal to 24, I can solve for that other one. I need both of them. Okay, once I solve this variable for y, that's only one of my two unknown variables. So I have to go back and solve for the x as well. But once you know what y is, it's easy. You plug in that number for y, and you can solve for x. So that gives me that x is 14. You can double check that this is right. The sum of these two numbers is 24, and their difference is 4. So these are right. Okay. So here's one more problem like this. Let's see. This one says a farmer has a total of 30 animals. They're pigs and chickens only. One day he counts the number of legs under the barn door and sees that there are 100 legs. How many pigs and how many chickens are in the barn? Okay, so I need to set up two equations. I have two variables. P I'm going to let represent the number of pigs. C is going to be the number of chickens. So we're going to start off with the first thing they tell us is that there's a total of 30 animals altogether. That means if I add the number of pigs plus the number of chickens, that should be 30. The other equation has to do with the legs. And the way we count up legs, since we know pigs have 4 legs, every one of these pigs has 4 legs. So I multiply the number of pigs times 4 to calculate the legs. Chickens have 2 legs, so I multiply the number of chickens by 2 to calculate how many legs are from chickens. And that total, the 4 times pigs and 2 times chickens, should give me the 100 legs that I have in total. So there's my two equations. Now I can start solving. This is the one that you want to use to isolate a variable because it's easier to isolate P or C in this equation. If you don't have a coefficient in front of that letter, that's the easier one to use. So now it doesn't really matter which one you do. I'm going to go ahead and isolate P. You could do C, it doesn't matter. You should still give you the same answer. And what's going to happen is I'm going to subtract C from both sides to get P by itself, and I get P equals 30 minus C. So that's your first step, isolate that variable, which we did. Second step, so that's step 1. Step 2 is where we substitute. We're going to substitute that 30 minus C in for P. Since they're equal, I can do that. That's the whole point. So I take this second equation, the one I didn't use already. Don't replace the 4. The 4 is still there. The 4 is being multiplied by the value of P. But instead of writing a P, I'm going to write the value of P as 30 minus C, since they're equal. And then I rewrite everything else in that equation. Plus 2C still gets repeated, and it equals 100. And what that does is gives us an equation that only has one variable, C in this case, so that I can solve for one variable. Distribute the 4 And go ahead and start solving this equation. Combine like terms. Minus 4 plus 2 is minus 2c. Subtract 120 from both sides. Don't forget that that negative 2c is what comes down. And on the other side is a negative 20, 100 minus 120. Divide both sides by negative 2. And we get that c equals a positive 10. So that means there are 10 chickens. So that's the chickens. We still need to figure out the pigs, so don't forget that. If there's 10 chickens, go back up to either one of these equations, this probably being the simplest, or even this one. It doesn't matter. You can go to any of your equations you wrote and replace your c with 10, since you know that c is equal to 10. I'll go ahead and use this one. Since we know that p is equal to 30 minus c, and c is 10, my number of pigs must be 20. And that's how you solve a system of equation, which is a problem that has two variables and two equations, using the substitution method.